Hi, welcome to this video on packet tracer activity investigating the TCP IP and OSI model in action. Here is our objective. Part 1, examine HTTP web traffic, and in part 2, display elements of the TCP IP protocol suite. In this packet tracer activity, we are going to understand the TCP IP protocol suite and OSI model. Here they're given some details in background. As data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. So each piece is assigned a specific name that is called the PDU, Protocol Data Unit, and associated with a specific layer of the TCP IP and OSI model. So packet tracer simulation mode enables us to view each of the layers and the associated PDU. So the following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on a client PC. So even though much of the information displayed will be discussed in more details later, this is an opportunity to explore the functionality of packet tracer and be able to visualize the encapsulation process. We will come to part 1, examine HTTP web traffic. In part 1 of this activity, we will use packet tracer simulation mode to generate web traffic and examine HTTP. So in that step 1, switch from real-time to simulation mode. Right. In the lower right corner of the packet tracer interface are tabs to toggle between real-time and simulation mode. Yes, we will do that. PT always starts in a real-time mode in which networking protocols operate with a realistic timing. So however, a powerful feature of packet tracer allows the user to stop time by switching to simulation mode. In simulation mode, packets are displayed as animated envelopes. Time is event driven and the user can step through networking events. So now we will click the simulation mode icon to switch from real-time mode to simulation mode, right? And we have to select HTTP from the event list filters. Here they're given 2 instructions, so we will go through that. HTTP may already be the only visible event. Click edit filters to display the available visible events. Toggle the show all or none checkbox and notice how the checkboxes switch from unchecked to checked or checked to unchecked depending on the current state. And to click the show all or none checkbox until all boxes are cleared, and then select HTTP. Click anywhere outside of the edit filter box to hide it. Right. The visible events should now only display HTTP. Now we will come to simulation mode. Here we can see that, right? And we have options here. Here we can see the event list filters, the visible events. Now it shows none. Here we can give show all, so that shows all the events, or we can remove it using this show all or none. Even we can edit the filters. So here we can come. Yes, here we can see that. Okay, if you click on this show all and edit filters, here we can see all the protocols enabled. Or if I remove that, we can see that checkbox are not selected, single checkbox are not selected, right? And we will select HTTP, so we have to go to edit filters and we have to select HTTP, right? And here we can see the event list filters. Visible event is only HTTP now here. Now we will come to step 2, generate web HTTP traffic. So currently the simulation panel is empty. There are 6 columns listed across the top of the event list within the simulation panel. As traffic is generated and stepped through, events appear in the list. The info column is used to inspect the contents of particular event. They given a note here. The web server and the web client are displayed in the left pane. So the panels can be adjusted in size by hovering next to the scroll bar and dragging left or right when the double-headed arrow appears. Click web client in the left in the far left pane. Click the desktop tab and click the web browser icon to open it. In the URL field, we have to give this URL, that is www.osi.local, and click go. Because the time in simulation mode is event driven, we must use the capture or forward button to display network events. Then click capture or forward 4 times. There should be 4 events in the event list. Look at the web client web browser page. Did anything change? Right, we have to do this, so then we will come to this question. Coming to the topology, here we can see the event list with a number of columns, and here we can see the info column. Right, here is our web client. We are going to click on this web client desktop, and we have to select a web browser, and we are going to give the URL here, www.osi.local, and we have to click go. Now we are going to click this capture or forward option here. We can see the packet here. Again, I'm going to give a capture or forward. Again, we are going to give a capture or forward. Right, and here we can see the web server page. You have successfully accessed the home page for web server. Yes, so look at the web client web browser page. Did anything change? Yes, we have seen that we got this web page from the web server. Now we will go to step 3, explore the contents of the HTTP packet. So click the first colored square box under the event list info column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. The PDU information at device web client window displays. In this window, there are only 2 tabs. One is OSI model and outbound PDU details. Because this is the start of the transmission, as more events are examined, there will be 3 tabs displayed, adding a tab for inbound PDU details. When an event is the last event in the stream of traffic, only the OSI model and inbound PDU details tabs are displayed. So ensure that the OSI model tab is selected. Under the OSI layers column, ensure that the layer 7 box is highlighted. And we got a couple of questions here. Before that, we will verify this. We will explore the contents of this HTTP packet. Now we will come to our simulation panel. Here we can see the event list, and here is our first packet, and here is our square box info. We are going to click on that. Yes, here is our PDU information at device web client, and here we can see 2 tabs, OSI model and outbound PDU details. Now we are in OSI model, and here we can see the layer 7 is highlighted now. Now we will come to the first question. What is the text displayed next to the layer 7 label? Okay, here we can see yes, it is mentioned HTTP. Right. What information is listed in the numbered steps directly below the inlayers and outlayers boxes? Yes, here we can see inlayers and outlayers. 7 layer information here. The HTTP client sends a HTTP request to the server. Now we will come to the next question. Click next layer. Layer 4 should be highlighted. What is the destination port value? Right, here we are going to click next to layer, and you can see now layer 4 is selected, and here we can see the destination port is 80. Right, click next layer again. Layer 3 should be highlighted. What is the destination IP value? Right, again we are going to press next here, next layer. So this layer 3 is selected, and here we can see the destination IP address 192.168.1.254. Yes, so click the next layer. What information is displayed at this layer? Right, again we are going to click next layer, and here we can see layer 2 Ethernet 2 header, and here we can see the inbound and outbound MAC address. Now we will go to next. Click the outbound PDU details tab. Information listed under the PDU details is reflective of the layers within the TCP IP model. So they given a note here, we will go through that. The information listed under the Ethernet 2 section provides even more detailed information than is listed under layer 2 on the OSI model tab. The outbound PDU details provides more descriptive and detailed information. So the values under destination MAC and source MAC within the Ethernet 2 section of the PDU details appear on the OSI model tab under layer 2 but are not identified as such. So what is a common information listed under the IP section of PDU details as compared to the information listed under the OSI model tab? With which layer is it associated? Right, we will check that. We will come to the PDU information. Now we will move to outbound PDU details, and here we can see the details, right? And yes, in the IP section here we can see the source IP and destination IP. Same thing we can see here in OSI model, I mean the layer 3 source and destination IP address. Next is what is the common information listed under the TCP section of PDU details as compared to the information listed under the OSI model tab, and with which layer is it associated? Right, here we can see the TCP. Yes, here we can see that. Here we can see the source port, destination port, etc. Right, so here we can see in OSI model. Here we can see that TCP source port and destination port. Yes, so it comes under layer 4, and here we can see source and destination port. Now we will come to next. What is the host listed under the HTTP section of the PDU details? What layer would this information be associated with under the OSI model tab? Right, coming here we can see outbound PDU details. Here we can see host www.osi.local. Right, so in OSI model it is associated with this layer 7. Now we will come to G. Click the next colored square box under the event list info column. Only layer 1 is active, not grayed out. Okay, the device is moving the frame from the buffer and placing it onto the network. And advance to the next HTTP info box within the event list and click the colored square box. This window contains both in layers and out layers. Notice the direction of the arrow directly under the in layers column. It is pointing upward, indicating the direction the information is traveling. Scroll through these layers, making note of the items previously viewed. At the top of the column, the arrow points to the right. This denotes that the server is now sending the information back to the client. Right, we will check these two now. Coming to the event list, here is our second square box. Yes, PDU information at device web client, and here we can see only layer 1 is enabled. Right, now we will go to the next info. Here it is. Yes, here we can see the in layers and out layers both are here, and here we can see the up arrow and down arrow which indicates the direction the information is traveling. Also we can see another arrow here pointing to right side. So this denotes that the server is now sending the information back to the client. Next is comparing the information displayed in the in layers column with that of the out layers column. What are the major differences? Right, we will come to the PDU information, and here we can see the layer 3. Here we can see the source IP address is 1.1, and when it comes to out layers we can see it becomes the destination IP. And here this destination IP, I mean here the source IP address is, here is a destination IP address. And coming to layer 2, Here we can see the MAC address becomes here the destination MAC address, and here the source MAC address becomes the destination MAC address. That means these addresses are just swapped. Now we will come to I. Click the outbound PDU details tab. Scroll down to the HTTP section. What is the first line in the HTTP message that displays? Right, we will check it. Here is our outbound PDU details. We are going to click on that. Now we will check for the HTTP. Yes, here it is, and we can see the first line, HTTP/1.1 200. Okay, so what it means? That means the request was successful and the page delivered from the server. Now we will come to J. Click the last colored square box under the info column. How many tabs are displayed with this event, and why? Right, here is our last square box. We're going to click on that, and here we can see we have only two tabs. One is OSI model and another one is inbound PDU details. So because this is the receiving device, that's why we get these two tabs. Now we will come to part 2, display elements of the TCP IP protocol suite. In part 2 of this activity, we will use the packet tracer simulation mode to view and examine some of the other protocols comprising of the TCP IP suite. Okay, view additional events. Step 1, close any open PDU information windows. In the event list filters, visible event section, click show all. What additional event types are displayed? Okay, right, we are going to check this now. Okay, here is our event list filters. Here we are going to give show all. Right, so we given show all option now. Yes, now we get more additional event types. Here we can see DNS, ARP, then we get TCP, right, HTTP there, right. So these extra entries play various roles within the TCP IP suite. If the address resolution protocol, that is ARP, is listed, it searches MAC addresses. Yes, we have seen that. Here is ARP. Yes, right. DNS is responsible for converting a name, for example www.osi.local, to an IP address, even vice versa. Yeah, so the additional TCP events are responsible for connecting, agreeing on communication parameters, and disconnecting the communication sessions between the devices. These protocols have been mentioned previously and will be further discussed as the course progresses. So currently there are over 35 possible protocol event types available for capture within a packet tracer. Great. Right, anyway, we are not going to see all the event type in this packet tracer itself. So click the first DNS event in the info column, explore the OSI model and PDU details tab, and note the encapsulation process. As you look at the OSI model tab with layer 7 highlighted, a description of what is occurring is listed directly below the in layers and out layers. So 1, the DNS client sends a DNS query to the DNS server. Yes, we will see that now. This is very useful information to help understand what is occurring during the communication process. Right, we will verify that now. Now we will click on this DNS info. Right, here we can see the details. Yes, here is DNS. The DNS client sends a DNS query to the DNS server. Right, now we will go to D. Click the outbound PDU details tab. What information is listed in the name in the DNS query section? Right, we will come to outbound PDU details and we have to search for, yes, here we can see DNS query. Yes, here we can see name www.osi.local. Now we will come to E. Click the last DNS info colored square box in the event list. Which device is displayed? Right, we will search for the DNS. Okay, yes, here we can see that. We are going to click on this. Yes, so this is a PDU information at device web client. Next is what is the value listed next to address in the DNS answer section of the inbound PDU details. Right, we have to go to the inbound PDU details and we have to search for the DNS answer. Yes, here we can see that. And here is address. Yes, 192.168.1.254. Right. Yes, so this is the address of our web server. Now we will come to F. Find the first HTTP event in the list and click the colored square box of the TCP event immediately following this event. Highlight layer 4 in the OSI model tab in the numbered list directly below in the layers, in layers and out layers. What is the information displayed under item 4 and 5? Okay, we will check that now. We will come to the event list here and we will search for the HTTP. Yes, here we can see that, and just after that HTTP we can see the TCP here, and now we have to go to the layer 4 and here we can see that 4 and 5 the TCP connection is successful. The device sets the connection state to established. Yes, so the TCP manages the connecting and disconnecting of the communication channel along with other responsibilities. This particular event shows that the communication channel has been established. Okay, now we'll go to G. Click the last TCP event, highlight layer 4 in the OSI model tab. Examine the steps listed directly below in layers and out layers. What is the purpose of this event based on the information provided in the last item in the list? Should be item 4. Right. Okay, we will come to this now. Now we will go to the last TCP. Here we can see that. Yes, and here is our layer 4 and here we can see the details. Informations: the device closes the TCP connection to the server on port 80. The device set the connection state to fin_wait_1. Yeah, it is going to close the connection. Yeah, that is going to happen here. Okay, they given a challenge here. This simulation provided an example of a web session between a client and a server on a local area network. The client makes a request to specific services running on the server. The server must be set up to listen on specific ports for a client request. So here look at layer 4 in the OSI model tab for port information. Based on the information that was inspected during the packet tracer capture, what port number is the web server listening on for the web request? Right, obviously it is 80, no doubt. The first HTTP PDU being requested by the web client shows port 80 under the layer 4 destination port. So what port is the web server listening on for a DNS request? So the first DNS PDU being requested by the web client shows a layer 4 destination of port 53. So in this event list we can see that coming to HTTP in the layer 4, here we can see the destination port 80, and coming to the DNS, yes, here it is, and here we can see at the layer 4 we can see the destination port 53. Yes, in this packet tracer activity we investigated the TCP IP and OSI model in action. Friends, if you have any doubt, please comment below. Also, if you like my videos, give a thumb, and don't forget to subscribe the channel right now so that you will get the latest uploading video into your Gmail. Bye bye.